And then for part D, it wants us to compute their CVij, okay? So compute CVij. In order to compute CVij, first, let me just write down the formulas to compute CVij, okay? So we'll use the chi-square test statistic, the square root times pi bar 1 subtract pi bar divide the sample size I plus pj bar 1 subtract pj bar divide nj. Okay, so this is the way that we can compute for CVij. So first, in this question, actually it doesn't specify the level significance, okay? But the most common level significance that we use was that alpha equal to 5%, okay, 0.05. So this is the commonly most popular one. So first we need to find out the chi-square at 0.05. We need to find out this value first. So how we can find out this value? We need to use the chi-square distribution table. So based on the chi-square distribution table, we also need to know the degrees of the freedom. So let me just write down the degrees of the freedom will equal k subtract 1, right? And then we have 3 populations, which means k equals 3, subtract 1 equal 2. So the degrees of the freedom equal 2. Then let's go to check our chi-square distribution table. This is the chi-square distribution table, okay? So first, you need to find out the degrees of the freedom, and in our case, okay, the degrees of the freedom equal 2. And then you can find out the alpha, the level significance, okay, equal to 0.05, which we can find out a chi-square statistic here equal 5.991, okay? So this will be our chi-square test statistic if the level significance equal 0.05. Okay, 5.991 at degrees of freedom equal 2. So let me just write down this number first. 5.991. Okay, then let me see if we want to compute CV12, okay, which means we need to compare with our P1 bar and P2 bar. Okay, so let me just write out CV12, which means we need to compare with P1 bar and P2 bar. It will equal 5.991, right? Times P1 bar, 1 subtract P1 bar, right? Divide the sample size for first sample size, okay? First sample, plus P2 bar, 1 subtract P2 bar, divide the sample size for the second sample, okay? So what we need to do is just put those numbers that from part C and then their sample size into this formula, okay? So we will have 5.991, the square root, times 0.7419 times 1 minus this proportion. Divide the sample size for 1, first sample, 310, plus for second sample, okay, 0.6154, 1 subtract 0.6154, divide the size, sample size of the second sample equal 130, okay? So based on those numbers, and then you can just put those numbers into calculators, you can find out this CV12 will equal, I just rounded, okay? 0.12 0.09. Okay, so this is the number I rounded. So let's continue to get a CV13, okay? So CV13 here will equal the square root of the 5.991 times, here we still have P1 bar, 1 subtract P1 bar, divide the sample size of the first sample, plus P3 bar, 1 subtract P3 bar, divide the sample size for the third sample, okay? So what we need to do, put all those given numbers. And then for the third sample, okay, 0.625, 1 subtract 0.625, divide the sample size, 160. Finally, we can get a CV13 will equal 0.1117. Okay, I also round it. So this number is rounded number. Then last, let's compute CV23. Okay, so CV23 will equal, just use this formula. But now we use the second sample compare with the third sample, right? Okay, so what you need to do is just plug all the numbers that we already know . And finally, you can find out this CV23 will equal 0.1403. This is also the rounded number, okay? So here, let me just summarize what we have compute from part D, okay? We have CV12 equal 0.1209, CV13 equal 0.1117, and CV23 will equal 0.1403, okay? Then let me construct a table and then to show you if there is a significant difference between those three different sample proportions, okay? So let me just write out part E. For pairwise comparison, if we use the first sample versus the second sample, okay? We first need to compute the absolute value between these two sample proportion, okay? So here we use .7419 subtract 0.6154, okay? So this will equal 0.1266, okay? We also have our CVij, okay, which is CV12 and CV12 here equal 0.1209, okay, this is what we have from here, okay, 0.1209. And then if it's significant or not, so significant or not. Do you still remember the significance criteria? So the significant criteria, I just write down here, okay? Significant criteria will be this absolute value larger than CVij, okay? So from first one, we notice this absolute value is definitely larger than CVij, so it's significant. Significant difference, okay? Which means P1 bar and P2 bar, those are very different from each other. Now let's look at if we use the first sample versus the third sample, okay? We have first sample proportion subtract the third sample proportion, which will equal 0.1169, okay? And then for CV 1/3 that we obtained is 0.1117. Therefore, it also satisfies this criteria, right? We have this number here larger than this number. Therefore, it's also significant difference between these two proportions. Last, let's compare with the third sample and the second sample, okay? So we use the absolute value, okay? So here we will have the absolute value. It will equal 0.90096, okay? And CV 2/3 as we got from here is 0.1403, right? So this compares these two numbers. It doesn't satisfy this criteria, okay? So we will see there is no significance happened in the third sample and second sample. Not significant. Which means for the female, if they shopping in the grocery chain or the discount store, they are totally different, okay? The proportions are different. For female, the proportions of the female shopping on grocery chain and membership warehouse, they're also different. However, there is no significant difference between the female's proportion shopping in discount store and membership warehouse.